Hi everyone. Today we are discussing about comparative study on large language models for healthcare investments. These are the contents, and this is the dataset which we have used as an example to compare between the large language models and the problem description and the goal. The problem statement is healthcare professionals need to be able to predict hospital stays in order to effectively manage resources, schedule patient treatment, and guarantee the best possible results. And the variance in hospital stay durations is influenced by several factors, including age, medical history, type of admission, and severity of sickness. As a result, this is complicated yet crucial prediction assignment. And the goal is as evidenced by a law root mean squared error and a high R squared value. The objective of this research is to develop a linear regression model that can accurately predict the length of a patient's hospital stay. Healthcare institutions that accomplish this aim will be able to make well-informed decisions based on previous length of stay projections, which will increase operations efficiently. And the prompt for the coming to the ChatGPT, the problem description is hospital stays vary greatly due to numerous factors, including a patient's medical condition, illness, and etc. And the goal is the objective of this project is to develop a predictive model using linear regression techniques. And this is the prompt which we have used for Gemini. And through this we aim to develop a model that predicts the length of time a patient will be staying in the hospital after being admitted, and a minimum root mean squared error which shows the discrepancy between expected and actual LOS. And coming to the llama 2, the information found in the search results may be used to predict the duration of the hospital stays, and this is the same which we have done through the Claude. And next slides will be continued by Vijay.
Yeah, for comparative study on large language models for healthcare investment, we uses 4 types of prompt models, and here we generate the code snippets for each large language models. Coming to ChatGPT, in this code sample, here we insert the data set in as a .csv file. It contains the attributes like location, time, hospital stay, MRI units, CT scanners, and hospital beds. That these with this data, every row displays information for particular year and place. For example, here we consider Australia along with healthcare resources and investments such as hospital beds, CT scanners, and MRI machines in order to investigate how hospital stay duration relatives rates to healthcare investment over time or across multiple regions. For example, this code lays the groundwork for additional research and visualization of patterns and correlation with the healthcare data. And coming to the next code snippet, that is Gemini. Here we can see the scatter plot that drawn by using the .csv file. Here the x-axis contains of MRI units and y-axis contains of hospital stays in number of days. And from this snippet creates a scatter graph to show the correlation between the length of hospital stay and the MRI units, CT scanners, and hospital bed. Every scatter plot displays one of the attributes on x-axis and length of the hospital stays in days on y-axis. The plots are designed to investigate potential relationships or influences on hospital stay duration between the number of CT scanner, MRI units, and hospital bed. This visualization helps with the additional analysis and insights into patient care and the use of healthcare resources by providing a preliminary knowledge of any connections or patterns that may exist between these factors. And coming to the cloud and Llama 2, by using here we use the Seaborn as SNS. The below code snippet creates a scatter plot that contains x-axis on as a location and for y-axis as a hospital stay. A particular location and length of associated hospital stay are represented by each point on scatter plot. This examines of any possible variations or patterns in the length of hospital stay in various places is by this graphic. Insights into possible variables impacting patient care and healthcare resources uses across various locations or institutions by provide the ability to quickly compare and comprehend now how hospital stay length vary regionally. And for the fourth cloud, here the snippets contains of high hues and various hues in the plot, which correspond to the various locations listed in the location column. Illustrate the trend of hospital stay duration over time for each line. The title of narrative which uses lessons to indicate the various places. Examine how hospital stays have varied over time at different places is made possible by this visualization, which offers insights into possible temporal patterns or trends in healthcare outcomes. Next slide will be explained by my friend.
Here we see the analysis of the solutions provided by each LLM. The first, ChatGPT error. The code failed because there was a string value US in the location column, which is expected to contain only numeric values. And the solution is to fix the issue, either remove the rows containing the non-numeric values or convert the non-numeric values to the numeric values using the p dot to numeric. With the errors, arguments replace non-numeric values with NaN. And the detailed explanation is the error message could not convert the string to float AUS, indicating the code is trying to convert a string value to a float, which is not possible. By removing or converting the non-numeric values, data frame will only contain the numeric values or correct the methods will be able to calculate the relations correctly. The strength and weakness using ChatGPT. Correctness. The code is accurate and functional across all tasks from data process, visualization, and modeling. The relevance is it directly addresses the healthcare data analysis problems, converting essential aspects, data exploration, and predictive modeling. Efficiency. The code structure is optimized, leveraging liberties effectively adhering the practices in data analysis and machine learning workflows. Clarity. Now coming to the Gemini, error explanation. The value error indicates the data error and encountered in a non-numeric value while calculated the correct correlation matrices. And the solution that is provided to resolve the error is the non-numeric column was dropped from the data frame and the drop method. The data corrected method was called the successful calculated and print the matrix. The strength and weakness using Gemini. The strengths are the code aim to visualize the correlations, which is printed to data analysis tasks. And the weaknesses are correctness, containing errors, especially in creating the correlation matrices, leading to incomplete functions. The efficiency is lack of errors, handling the comments, reducing efficiency and clarity. The clarity is, my friend will continue the lamina too.
So similarly, there are similar advantages and disadvantages for different LLMs. And coming to the conclusion, and yeah, the overview of the health care resources and hospital stay duration. The timeline from 1990 to 2015 shows the various healthcare metrics like hospital beds, MRI units, and CT scanners, and hospital stay durations. The visual aims to illustrate the trends and potential relations between these factors over the time. And also the correlation analysis calculates the relationship between the hospital stay duration and variables like time, MRI units, CT scanners, and hospital beds. Also, the positive values indicate a strong relationship, while the values around zero may imply no significant correlation. Uh, the correlation matrix visualization. The heat maps reveal strong positive correlations between MR units and hospital stay duration and between CT scanners and hospital beds with hospital stay duration. The correlation between MRI units and hospital beds is weaker. This helps identify key variables of predictive modeling. And going to the predictive modeling, the data set was split into training 80% and testing is given 20% sets to build a linear regression model. The mean squared error MSE is approximately 6.3 and R squared value is around 0.07, indicating limited predictive power. And the conclusion of the comparative analysis of different LLMs is the analysis shows trends in healthcare resources availability and their potential influence on hospital stays. Significant correlations guide feature selection for predictive modeling. Despite limited predictive power, the model offers a starting point for improving hospital stay duration predictions, aiding better resource planning. Thank you all.